So this is an AP for response question on the AB exam from a couple years ago. So kind of read through and see what they're telling us here. And this is a calculator active problem. So it says the rate at which people enter an amusement park is given by this equation, E of t. The rate at which people leave the amusement park is given by this equation, L of t. Both E of t and L of t are measured in people per hour. So the units on this is people per hour. The units on this is also people per hour. So t is measured in hours after midnight. And these equations are only valid from 9 to 23. Okay? And at time t equals 9, there's no people in the park to start with when the park opens. Okay, first question. How many people have entered the park by 5 p.m.? So I want to know how many total people have come into the park at 5 p.m. So I need to use this equation. These are the people entering. And 9 is when the park opens, so that's when I'm going to start. 5 p.m. is equivalent to 17, so those are going to be bounds. If I integrate the rate, I should get the total number of people. So this is what I'm going to integrate, and you can check for yourself if the units make sense. Again, this is people per hour. Units on this is hour. So notice you will get total number of people as my answer. Notice it does say to round to the nearest whole number. So this is your setup that you want to show. Type this into your calculator, integrate it, and you should get 6,004 people total. Okay. Next question. The price of admission is $15 until 5 p.m. So that's all these people only had to pay $15. After 5 p.m., the price is only $11. How many dollars are collected from admissions to the park on any given day? Okay, so these people here, they got in by 5 p.m., so there was a total of 6,004 people. They had to pay $15. So that, I can just do 6,004 times $15. Now, there's another set of people who are coming in after 5 p.m., so that's going to start from 17, and then the park closes at 23, and I need to, again, count how many total people have entered. So these are the total number of people entering from 5 p.m. till the park closes, and these people are going to end up paying $11. So whatever this number is, we're going to multiply by 11. So this would be the total amount of money that we collected. Use your calculator. It does say round to the nearest whole number, so don't give them the decimals. So $104,048 is what you should get from the calculator. Okay, next. They're telling me that H of 17 is 3,725 people. Look at what H of 17 is. They've defined H of 17 is the integral of the rate at which people entering the park minus the number of people who have leaving the park. So this number here, so when you integrate E of t, remember up here we get to people. If you integrate L of x, they're using x here because they use t here. This is also people. So H of 17, the units on this is people, right? So what this means is this is taking the total number of people who've come into the park, subtracted off the people who have number of people who have left the park. So this is the number of people who are in the park at exactly 5 p.m. because 17 corresponds to 5 p.m. Now we need to find h prime of 17. So think back to our second fundamental theorem. Before you plug in the number, go ahead and take the general derivative. So if I take the derivative of h of t, I get h prime of t. What do we do when we take the derivative of an antiderivative? We're going to just plug this t in for x. So h prime of t is really the same as e to the t minus L of t. I want to know what happens at 17, so I'm going to plug in 17 here. Okay, so you're going to plug in 17 here, get e of 17, plug in 17 here, subtract those two numbers on your calculator, and if you do that, this ends up being negative 380. And again, it says, let's do it in the context of the amusement parks. So 0.281, since we're talking about people, we can round it off to the nearest whole number. So this is saying at t equals 17, which is 5 p.m., so at 5 p.m., this is your rate. So the units on this is going to be people per hour. Notice that your number is negative. So we're going to say the number of the people in the park is decreasing at a rate of 380 people per hour. That's your explanation for this number here. Okay. Lastly, at what time does the model predict that the number of people in the park is a maximum? Okay, so as soon as you hear those words, maximum, you should be thinking, okay, my only possibilities are my endpoints, which are 9 and 23, and any critical numbers. So the total number of people in the park is given by this equation, so we need to figure out when is this, which we came up with this, which is this, going to be equal to 0. This you're going to solve on the calculator. This is your y1, this is your y2. Find your intersection, you're going to get to here. Okay, and I would store this as a letter A, or whatever letter that you want. And then how do we find the absolute max? If there's no word relative in front, remember it means absolute. We take all our possibilities and plug it back into the original function, which is this function right here. So I need to find h of 0, oops, not 0, h of 9. I need to find h of 23, and I need to find h of this number that I called a. You're going to use your calculator, plug it into here. 9 to 9, this will give me 0 since the bounds are the same. 9 to 23, this entire function. 9 to a of this entire function. And this will give me, maybe it's 19, 18, something. This is 39, 50. So this is my max. That's the highest value.